Here is the semester exam review covering the radical equations. So number 1 says the square root of x plus 3 equals 7. So remember, you're trying to solve for x, and you need the radical to go away. So you undo a square root by squaring it, and whatever you do to one side, you have to do to the other. So if we square both sides, when you square the radical, it goes away. You're left with x plus 3 equals 7 squared, which is 49. All right, so then it's just a linear equation. You need the plus 3 to go away. You subtract 3 from both sides, and you end up getting x equals 46. And when you check for extraneous solutions, it just means make sure if you plug it back in that it works. So if I plugged 46 in, 46 plus 3 is 49, square root, that's 7. So we're good. Okay, so number 2, I have a radical equals a radical. So remember, there's no isolating the radical because there's 2 of them. So you have radical equals radical, and if that's the case, you can just square both sides to make each of those radicals go away. So I end up with 4x plus 20 equals x plus 2. So then we're just going to use inverse operations. I know I can move that x over, and I'm going to subtract the x there. Okay. By doing that, it gives me 3x over here. But I also know I need that 20 to go away, so I'm going to do it at one time. I'm going to also subtract 20 and subtract 20. And when I do that, I know that goes away, right? This goes away here. So I'm left with negative 18. So I just did both things. I moved this x and I moved that 20. So then you divide by 3, and you get x equals negative 6. So then when I go back with that negative 6 and I plug it in, I get 4 times negative 6 is negative 24, plus 20, that's negative 4 in that radical. We can't have a negative in there. So no negatives in the radical, remember? And the square root can't equal a negative. All right, so no negatives in the radical because we're only dealing with real numbers. So this is no solution, because when I plugged that negative 6 back in, you get the square root of 4 times negative 6 plus 20. Okay, that is square root of negative 4, and we don't want that, right? It does end up equaling square root of negative 4 equals square root of negative 4, but we're not dealing with complex numbers right now. All right, so number 3, state the domain. So remember, the domain algebraically is just what's underneath the radical. You take that and you set it greater than or equal to 0. And then you solve. Well, we add 4 to both sides. When you add 4 to both sides, you get x is greater than or equal to 4. All right, here, 2x plus 5 is greater than or equal to 0. I'm going to solve. It's just an inequality. All right, so I'm going to bring that over here. 2x is greater than or equal to negative 5. Divide by 2 on both sides, and you get x is greater than or equal to negative 5 over 2. So that is how you find the domain algebraically. You take what's under the radical, set it greater than or equal to 0, and solve for x. Okay, so now we're going to graph the square root and the cube root. So 5 and 6 are square root. I know they're square root because there's nothing up here in the index. When there's nothing in the index, remember, it is implied that it is a 2. It's a square root. Okay, so I don't know if you remember, but you always plot. So for these, you always, for square roots, we'll put this here, square roots, you start at 0, 0, and you pass through the point 1a. So you start at 0, 0, pass through 1a. So I need to know what a is, right? All right, I need to know a, h, and k, because I do have to move this. So, all right, a is what's in the front. Well, there's an understood 1. H is the horizontal shift that comes from here. It comes out opposite, so it comes out as a positive 2. And K is in the back. So K is 4. All right, so we always start at 0, 0, and we pass through the point 1, comma A. So in this case, A is 1. It's a 1, 1. So I start at 0, 0. I pass through this point, and it gives me this general shape. If you remember, start at 0, 0, pass through. That helps you know the direction it's going to go. So that's the first part. Then I'm going to shift it horizontally and vertically. So my horizontal shift is 2 to the right, and my vertical is up 4. So this right here tells you to go right 2 and up 4. So I take 0, 0, and I go right 2, up 4. This one goes right 2, up 4, and there's my graph. All right, so essentially this dotted one could go away. We're only dealing with the solid one right now. So my domain is from the left to the right. What is the ordered pair right here, basically? So that ordered pair is 2, 4, right? Okay, so the x value that you're starting at is 2, and you're going over to the right. So 2 over to positive infinity. Bracket at 2. Parenthesis at positive infinity. And algebraically, you could look. You take that x minus 2. You set it greater than or equal to 0. When you add 2, you get your domain. It's the same, right? Greater than or equal to 2. Okay, 2 to positive infinity. Your range is bottom to top. Well, what's the y value you're starting at? 4. And the graph opens up to the top. And you get a bracket, closed circle. All right, so number 6. A is negative 2/3. H, in here the opposite, that's a 3. K is what's back here in the back. There's nothing, so it's a 0. Okay, so here we're going to start at 1A, which is negative 2/3. Okay. All right, so here we go. You start at 0, 0. Oh, and look at the front right here. What do you guys... Oh, no, go back. What do you notice? There's an x-axis reflection. Okay, so that means it's going to flip down this way, right? So you start at 0, 0, and you go to the point 1, negative 2/3. 1, negative 2/3 is somewhere down there. See what it's doing? That negative 2/3, if you start here and pass through, it's taking care of that reflection for you. Okay, so then you shift this to the right 3. You don't move it vertically. So this guy's going to go 1, 2, 3 to the right. This guy goes 1, 2, 3 to the right, right over here. Oop. You get the idea. There's your general shape. So domain is from the left to the right. We're starting right here. That's the point 3, 0, right? So I start at 3. That's just the ordered pair, so I see the x and the y. 3, and I'm going to the right. So 3 over to positive infinity. Bracket at 3. Now my range, here's what you got to notice. Down here at the bottom, I got graph down here, right? This guy's going to keep on going, right? So you're starting actually at negative infinity this time, and you're going up to this point and stopping at that y value of 0, and it gets a bracket. And again, algebraically, x minus 3 is greater than or equal to 0. If you solved it, you get x is greater than positive 3. So square roots are the point 0, 0 and the point 1a. Cube roots, if you remember, they have this 3 up here in the index. That's how you know it's a cube root. They start at 0, 0. They pass through 1a. But remember, they also pass through negative 1, negative a. So they get that third point. It's a cube root. It needs 3 points. Okay? All right, so my a here is negative 2. Remember, the 3 is in the index. That indicates a cube root. H comes from inside. It comes out as negative 4. K is what's in the back. Well, there's nothing back there, so K is 0 here. So this time, using your A, you get the point 1A, and you get the point negative 1, negative A. So you actually get 2 points this time. And we also still have 0, 0. So 1A is going to give you 1, negative 2, because A was negative 2. Okay. Negative 1, negative a is going to give you negative 1. And then negative a, negative, negative 2 gives you a positive 2. Okay. So I always start at 0, 0. I pass through 1a. So that's 1, negative 2. Oh, look at that. And negative 1, positive 2. Look. So usually these take this shape right here. Okay. But notice there's an x-axis reflection. So it takes this and it's going to actually flip this guy so that it does this, right? So this red right there, that's an x-axis reflection. That's what it does to it. And if you start at 0, 0 and you pass through 1A, well, when you do that, it has to curve this way. And when you go the other way, it has to curve this way. Remember, we don't connect the dots vertically, okay? Vertically is a cubic function, and this is a cube root. These are inverses, right? So you don't connect it like the red that I just did right there, because that's a cube root, or a cubic. You want it purple, it's a cube root function. So the cool thing about these, remember, hopefully you do, the domain and range is all real numbers. This goes from left to right and up and down, never stops. So negative infinity to infinity and negative infinity to infinity. All right, so last one. My 3 out front's the big 3. The little 3 is the index. So my A is 3. H, notice there's nothing in there. This guy is in the back. That's a K. H has nothing. K is negative 4. All right, so you get 2 points. You get 1A. You get negative 1 negative A. All right, so if A is 3, I'm going to get 1, 3, 1A, 1, 3, negative 1, negative 3. So I have the points that I need. You always start with 0, 0. That's for all of them. You always start at 0, 0, and you always use 1A. Pass through 1A. There we go. 1, 3. If this were a square root function, that's what it looked like. But it's a cube root. Cube roots have 3 points. Negative 1, negative 3 down here. And we pass through and we curve this way. We know it doesn't connect vertically because it's not a cubic, it's a cube root. So it has to curve out to the sides, kind of like the radical does, over to the side to give it a house, right? All right, so then I'm going to shift horizontally none, and I'm going to shift down 4. So 0, 0 moves down 1, 2, 3, 4. 1, 3 moves down 1, 2, 3, 4. And negative 1, negative 3 moves down 1, 2, 3, 4, all the way at the bottom down there. And then we connect the points. And again, negative infinity over to positive infinity. And that's it. All right, so I will go back full view so you can look if you need to. So here is all of this over radical equations.